Hello folks, this question belongs to, let me write the code here. It is 1 2 February, March and 19, the fresh questions just released, and it is question number 28, and the question belongs to the chapter of superposition of waves. It says that two identical loudspeakers are connected in series to an AC supply. So loudspeakers series. So when they are in series, they will receive the same current, and if they are identical, the power or the energy they receive is also same. A microphone is moved along the line PQ. So from here to here, we move the microphone. So that means the microphone will detect sound from the speaker as well as the background sound. So here we are not told that it just receives the sound from the speakers. It receives sound from outside as well. So background sound is also there. So which graph best shows the variation with time with distance from P of the intensity of the sound detected by the microphone? So we have to find the variation of the intensity here. So if I consider the interference phenomenon only, so what I must have is in the middle point somewhere around here, the intensity should be highest, then it should go to 0. So it is minimum, which we call as, this is max, and here it is again minimum, again it is a max and minimum, and again it is max, minimum, and so on. So had we had only the speakers and not background radiation, so here will be max, this will be 0, max, and so on. But since we have the background radiation, so what we must have is the minimum will not be 0 because of the background. So that's why this thing and this thing, they disqualify. And the next one is that what we should have is here the intensity should be higher. It's because it lies exactly in the middle compared to this. So intensity should be slightly lower here because of small losses because of the difference in the distances. So here again it should be slightly lesser because of the difference in the distances, because we know that IE is proportional to 1 by r square. So if a distance increases, the intensity will definitely decrease because of each of them. So that's why the maximum intensity also goes on being less and less as it goes from the center. So when it comes from here, it should be less in the beginning, slightly more, maximum here, slightly less, slightly, and so on. So going through that, our choice should be C should be incorrect and A should be correct. So now in order to clarify it, let me just give some numerical values and do this even more clearly. So let us say the background intensity is, because of the all these things, is equal to maybe say 2, and say this is 10 and this is 10. So when there is addition or max here, so 10 and 10, 20 plus 2 is, this is 22, and here we have got 10 minus 10 is 0, but what happens is, so this 2 is there, so it's equal to 2, and also it's equal to 2. And here what we have is the distance decreases, so that's why the intensity might not be the same, and that's why the maximum will be slightly decrease, and so on. So what happens is, since I was saying that the minimum isn't equal to 0, it's because of the background radiation there. It's not because of these things, but because of the background there. So choice A should be the correct answer.